Hello everybody. Today I want to have a discussion about recent advances during last decade in cables, insulation systems and SF6 free switch gears. As you know, high voltage networks depend on cables, insulation systems and switchgear for reliable operation. In the last decade, the major advances have focused on performance, reliability and sustainability of these systems. HVDC cables and their technology have reached the higher voltages and longer distances. On the other hand, insulation research has improved the material properties and monitoring methods. And also, SF6 free switchgear has become a reality which is driven by the climate regulations. Why these components matter? Cables are the arteries of transmission carrying bulk power over the land and sea. Insulation systems ensure reliability and safety under the high stresses and high tensions. Switchgears protect and control the grid during the fault issues. Failures in any of these areas can cause the long outages and major costs. Recent R&D activities have targeted both technical improvements and environmental impacts. But about the advances in high voltage DC cables or HVDC cables, I would like to tell you that during last 10 years ago, HVDC cables were limited in voltage and distance, especially for offshore applications. But today, uh, 525 kV XLPE subsea cables are being deployed in Europe and Asia. These cables can transmit several gigawatts over hundreds of kilometers. Improved manufacturing and testing have reduced the failure tests. Then we can say that this has enabled the massive offshore wind integration projects. About insulation materials and interfaces, I would like to tell you that research over the last decade has focused on XLPE space charge behaviors under the HVDC stresses. New additive and nanofillers improve the conductivity and thermal properties. Interfaces such as joint and terminations remain the weak points, and this is an important issue in the when we are facing with solid insulation materials. Better manufacturing and insulation practices have improved the reliability. And on the other hand, condition monitoring systems now detect the early signs of insulation degradation. But about the online monitoring and diagnostics, I would like to tell you that digital tools have advanced rapidly in the last decade. Distribution temperature sensing and acoustic systems monitor the cables in a real-time condition. On the other hand, partial discharge or PD detection during the using UHF and fiber optics is now widely used. And another important issue is that data analytics and AI help to predict failures before they happen. This shift to the predictive maintenance has reduced the costly outages. But about the development of SF6 free switchgears, I would like to tell you that SF6 has been the standard insulating gas, but it is a very potent greenhouse gas, and it is a big issue in for people who are concerned about environmental issues. In the last decade, OEMs have developed the alternatives such as fluoronitrile blends and clean air mixtures. Pilot projects since 2016 have proven SF6-free GIS gas insulating systems at the transmission levels. By 2020 to 2025, several utilities have adopted these systems in the new installations. These technologies now offer similar performances with the lower environmental footprints. But there are some practical challenges when we want to deploy these systems. SFC-free equipment often requires slightly larger dimensions. And on the other hand, new gases may need special handling and training. And another important issue is that retrofitting existing SF6 equipment is not always possible. However, utilities must be updated, must update the maintenance procedures and standards. Despite challenges, adoption is accelerating due to the regulations, and this is a very good news. I would like to mention some case studies from last 10 years in the field of HVDC power transmission using HVDC. Europe's North Sea wind projects rely on 320 to 525 kV HVDC cables. China has deployed record-breaking land HVDC links which exceed 3,000 kilometers. Switzerland and Germany have piloted SF6 free GIS at 145 kV and above. Australia has begun adopting the advanced insulation monitoring for the long distances. I mean the Marinus project from Victoria to Tasmania. These case studies show the progresses from the lab to the real-world systems. But about the future directions, cables are moving toward 640 to 800 kV HVDC capabilities. Research continues on biodegradable and recyclable insulation materials. On the other hand, SF6 ferry technologies are expanding to the higher voltage classes up to 420 kV. Digital twins of cables and switchgears will improve the diagnostics. The next decade will focus on the scaling these advances globally. I would like to conclude this discussion, and I want to tell you that during the last decade, during the last 10 years, HV cables, insulation systems, and switchgear have advanced dramatically. XLPE HVDC cables now enable the global scale renewable integration, which is very much important in the field of renewable energies. Insulation science has improved the reliability with the better material and monitoring. SF6 ferric switchgears or SF6 switchgear is reducing the carbon footprint of industries. And finally, these advances are shaping a cleaner and more resilient high voltage grid. Thank you for your attention.